So 2014 C3, question 7. Find the exact, that means we'll have roots in our answers, equation of the tangent to this curve. So let's structure our question by writing out the formula. We're told that x equals pi over 4. So let's work out the y coordinate. So the y coordinate there is tan 2 times x, 2 times pi over 4, take away pi over 6, cos pi over 4, add pi over 12. That tidies up to tan a half, take away a sixth is a third, so it's tan pi over 3. Cos a quarter plus a twelfth is also pi over 3. So tan pi over 3 times cos pi over 3. Tan pi over 3 is your root 3. Cos pi over 3 is a half, so that's your y coordinate. So we'll just plug that in. Y minus the y coordinate equals mx minus the x coordinate. Now, to work out m, I've got to differentiate our expression up here. So dy by dx. Tan goes to sec squared. The derivative of this bracket is 2, so it goes in front. Sorry, it's a product rule. So u equals the first term, and this is du by dx. V equals the second term. So dv by dx, cos goes to minus sine. Derivative of that's just a 1. Now using the product rule, dy by dx is u dv by dx plus v du by dx. U is tan 2x minus pi over 6. dv by dx is this expression here, so it's minus sine x add pi over 12 plus v cos x add pi over 12. du by dx is this expression here, so it's 2 sec squared 2x minus pi over 6. We know that the x is pi over 4, so he's going to sub that in now. So dy by dx is tan 2 times pi over 4 is pi over 2. Take away pi over 6 gives me pi over 3. Minus sine pi over 4 plus pi over 12 is pi over 3. Plus cos pi over 4 plus pi over 12 is pi over 3. 2 just times this by 2. Sec squared is over 1 over cos squared. Putting your 2 in, 2 times pi over 4, take away pi over 6 is also pi over 3. Just working those out. Minus tan pi over 3, sine pi over 3, plus pi cos pi over 3, and cos pi over 3 squared is a quarter. So that all tidies up to give me minus 3 over 2 plus 4. So 4 take away 1.5, 2.5, or 5 over 2. So plugging that back into our equation over here, y minus root 3 over 2 equals m x minus pi over 4. I'm going to multiply everything by 2 here, just get rid of that fraction. Expand out the bracket. 2y minus root 3 equals 5x minus 5 pi over 4. Multiply everything by 4, just to get rid of that fraction. And you're just going to put everything on one side. So 20x minus 8y plus 4 root 3 minus 5 pi equals 0. I also have to do question 8 from that paper. So question 8, it says, part 1, find dy by dx of that. So y equals minus, I'm just going to put the minus in the top line so I don't lose it, minus log x ax. So obviously that's the quotient rule. Sorry, yeah, the quotient rule. U equals minus log x du by dx minus derivative over function. V is the bottom row, dv by dx, derivative is 1 ex. quotient rule, dy by dx is v, du by dx minus u, dv by dx all over v squared. V is ex, du by dx is minus 1 over x minus u, so it becomes plus log x. dv by dx is ex all over v squared, so ex squared. And yeah, we can just leave it like that. You can divide through by the ex if you want, but that's okay to leave it. Part 2 of that question says, show that the x-coordinate, the stationary point, is this equation. So the stationary point is when dy by dx equals 0. That's why I didn't worry too much about tidying that up, because I knew it was going into the stationary point, and the bottom line was going to disappear, because when you bring that bottom line up to our side, you're timesing it by 0, meaning I'm left with ex minus 1 over x plus log x, ex equals 0. I can factorise out my ex. So ex equals 0, or this bracket equals 0. To get rid of an e, you log each side. Log 0 doesn't exist, so there's no solution there. And if I rearrange that, I get log x equals 1 over x, which is what the question was asking you to find.